All right, why? If you do like e to infinity, it would eventually go to infinity. Like so, it wouldn't be 0 if it was e to infinity. But for this first one, we don't have just e to the x. What do we have? Negative exponents. How can we rewrite negative exponents? 1 over, right? And we can't send these to the other side of the fraction bar because we have those plus and minus signs. So we could write it like this. 1 minus 1 over e to the x. Oh, sorry. There we go. Minus 2 plus 1 over e to the 2x. So if you think about what's going to happen, if you have, 1 over e to the x, if you plug in numbers, you'd have like 1 over e to the first, and then 1 over e to the second, 1 over e to the third. So what's happening to that denominator? It's getting bigger and bigger and bigger, which means the whole fraction is getting closer and closer and closer and closer to 0. So this, even though it's not x to a power, it's e to an x, this is going to go to 0 just like 1 over something will go to 0. 1 over x to a power will go to 0. Same thing down here in the denominator. That's also going to go to 0. So if those go to 0, then we're just going to have 1 minus 0 over 2 plus 0, which is 1/2. So we should get 1/2 for this problem. So if you see negative exponents on something, you want to get rid of those before you try to do the problem. That would also be the case like if we had 1 minus x to the negative 4th instead of e to the negative x. That would also be the case there. You would want to rewrite that as 1 minus 1 over x to the 4th before you tried to decide what this limit did. So if you see negative exponents, rewrite those as fractions and then think about what would happen. All right. Questions on number 1? All right, number 2. What do you guys think? Basically, sort of. So, Bobo Botno Eats DC says that if it's bigger on bottom, it would be 0. If it's bigger on top, then not 1, or it's going to be infinity or negative infinity. And then exponents are the same, divide coefficients. Question is, which one do we have here? It's not bottom. And here's why. Let's go to Desmos on this. Here's why. If I've got f of x, if I've got x to the 6th power, that's going to have, it's a really steep line, right? But if I look at e to the x, okay, and I'm going to go over here with the wrench, and I'm going to make my y really big, so probably have to zoom out even more. Okay, so I had to zoom out really far. But this red graph right here, that is my x to the 6th. Right? The blue graph is e to the x. So right here, like if you're just zoomed in normal, it looks like x to the 6 is much bigger than e to the x, right? But e to the x is exponential. And exponentials are always going to eventually overtake x to any power. You'll have to go way out a lot of times for that to happen. But this e to the x is going to eventually grow a lot faster than the x to the 6th. So we are more or less going to use Bobo Botno here, but let's make ourselves a note. E to the x is greater than x to the, I'm just going to put r power there, right? For x approaches infinity. So for large numbers, your e to the x is actually got a higher degree than that x to the 6th. So we can basically do Bobo Botno HCC here. This one, though, would be bigger on top because that e to the x is going to be your highest exponent, even though it's not directly comparable to the x to the 6th. So, since that e to the x is negative, what is our answer for this going to be? Negative infinity, right? So whenever it's bigger on top, you do want to look at the sign in front of whatever has the highest degree, because that will affect what you get there. Yes. So if we think about what's happening with these numbers, all of these numbers are going to get larger, right? So 4x, that number's going to get larger. E to the x gets larger, 9x to the 6. All those numbers are getting larger. So it's almost sort of like a race, like which one's getting larger faster. And so x to the 6, it gets bigger faster than just 4x, right? Because its exponent is higher. But e to the x is going to get bigger the fastest. So this is going to be the number that is going to really control for large numbers what you're getting. Because this has got that minus in front of it, you're going to have, you'll have, like if we plugged in 100, right, we would have 4 times 100 minus e to the 100 over 9x to the 100. I'm sorry, 9 times 100 to the 6th. So what happens is that e to the 100, hopefully I picked a big enough number, should be like our biggest number. So it controls what is happening there. And because it's got that negative right there, you're doing 400 minus a really, really, really big number, which is going to give you a negative in that case. So whichever thing that you have that has the highest degree, you want to look at the sign in front of it, that whatever term has that highest degree. And that will tell you positive or negative. All right, now 3, hopefully you saw here that limit, this is limit as x approaches negative infinity. Okay? With e's, this makes these problems weird. Okay? Because if this was positive infinity, you don't even have a fraction here. These numbers will just get bigger and bigger and bigger and bigger and bigger. Does that happen as x approaches negative infinity? Think what's going to happen. Like if I plug in, I've got 3 plus 4e to the negative 1. Well, that is really 3 plus 4 over e, right? And if I do 3 plus 4e to the negative 2, that's really 3 plus 4 over e squared. And if I did 3 plus 4e to the negative 10, that's 3 plus 4 over e to the 10th. What's happening here? Because this is actually getting smaller right here. One way we can actually think about this is we could write this limit like this. I could change this to make this the limit as x approaches infinity. But if I change this as x approaches infinity, that means I'd have to put the negative over here with the x. Right? Would the same thing happen here? if I did that, because x is our only thing, our only variable, right? And so if I put the negative here, still as I plug in numbers, x is approaching infinity, but we would have, it'd be -1, -2, -10, -100, -1,000,000, and so forth. So I can rewrite it like this. Then I can think of it like I did number 1. This is really the limit as x approaches infinity of 3 plus 4 over e to the x. And 4 over e to the x, that is going to go to 0. So we'll just get 3. 0. Yes. Yeah. It does not have to be 1, no. Any number, because even if it was like a gazillion, eventually, as x approaches infinity, it would eventually go to 0, because that e to the x, that exponential nature just really takes off there. So this is what we would get here. So e's are a little bit tricky, particularly you want to pay attention when that x approaches negative infinity. If you have e's and x approaches negative infinity, it's probably your best bet is to change it to a positive infinity and make all of your x's in the problem negative, and then think of it that way. Because these can be a little bit tricky. Alright, so infinite limits we're going to look at today. Yesterday we talked about limits at infinity, which meant that x was approaching infinity. Infinite limits are limits where the answer is infinity. You could have one that is both. So you can have x approaching infinity and your answer being infinity. So that would be a limit that is at infinity that is also an infinite limit. But what we're going to focus on today is limits where our answer is infinity, even though we're not looking at x approaching positive or negative infinity. So if you think about what's happening here, if as you approach a value, you go up to infinity or down to negative infinity, you're looking at places where you have vertical asymptotes. So the definition of a vertical asymptote is that if limit as x approaches c from the right of f of x equals positive or negative infinity, or the limit as x approaches c from the left of f of x equals positive or negative infinity, then x equals c is a vertical asymptote of f of x here. So it can be either side. It does not have to be both sides. So sometimes you have vertical asymptotes where they both approach the same from both sides. Sometimes you might have one side approaches positive infinity, one side approaches negative infinity. Sometimes you have vertical asymptotes, like particularly I'm thinking of like log functions, where you only approach from one side, but it's still called a vertical asymptote there. So it doesn't have to be both sides. It could be either or. We've talked about vertical asymptotes before and finding what causes them. So any value that causes the denominator of a simplified function to equal 0 will be the location of a vertical asymptote. This says here, simplified function. That means whenever you're simplifying it, that means that you have already canceled. Because what happens when we have factors that we can cancel on top and bottom? What kind of discontinuity do we have there? What? Yeah, if it does cancel, what do we have there? Removable. We've got a removable discontinuity or a hole in the graph. But after we've already canceled, if we still have a 0 in the denominator, that is where we have a vertical asymptote. So we've talked about this before. If we're just looking for vertical asymptotes, here, there's nothing to simplify here. Can't factor the numerator. we're going to have a vertical asymptote at, what is my vertical asymptote going to be? X equals negative 2. All right, plug in negative 2 there, gives you a 0 in the denominator. All right, the second one, can I factor? Can I factor x squared plus 4? I cannot, because it's got that plus sign. But I could factor the bottom into x plus 2, x minus 2. Is it going to cancel with the numerator at all? It will not, because we can't factor it. So we're going to have two vertical asymptotes. For this one, x equals positive 2, x equals negative 2. We've done these before. This is familiar. Everybody feel okay with them? All right. Cotangent. Ooh. Cotangent. First of all, cotangent has asymptotes. And it's going to have a bunch of them, right? Because it's a trig function. It repeats over and over and over. You just got, you know, like the squiggle, 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 squiggle for all eternity there. So we need to figure out where that is going to happen. So without graphing this and thinking about this, cotangent, what is its? It is cosine over sine. So we could make this cosine of pi x over sine of pi x. So we're going to have asymptotes whenever sine of pi x equals 0. Right? So the numerator, we don't really care about it because it's not going to give us asymptotes. It's that denominator that we care about. So if I think of my unit circle, I need to grade those quizzes for you guys. If I think of my unit circle, sine is going to equal 0 right here at 0, and then also over here at pi, right, 0, pi, and then 2 pi, 3 pi, 4 pi, 5 pi, and so on, right? So sine is going to equal pi x at pi, or pi x, if pi x equals, I'm going to call it this, k times pi, okay? And I'm going to put a little asterisk right here that says k is an integer. So that means it could be, you know, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, negative 3 pi, negative 7 pi. It's all increments of pi, right? But the pi is already inside of that parenthesis, so it's not just whenever x equals k pi, it's whenever pi x equals k pi. So if I want to solve that for x, what should I do? Divide by pi. And so x equals k, where k is an integer. So it's basically just all the integers at 0, 1, 2, 3, 4, 5, and so on. Yeah. So we couldn't say all real numbers because all real numbers would include decimals and fractions, which would not be true. So it would have to be integers, yeah. All integers. Integers are inherently real, so the real there is unnecessary but correct. So if you prefer all real integers, it is not wrong to say that. I'm pretty sure there's not a symbol. Yeah. if you do make up your own symbol. Oh, that would be. But, yeah, but you need an I. Yeah, all right. I will say this. On the AP exam, you cannot make up your own symbols that you use throughout the class. But if you define it, if you say on the problem, let I equal all real integers, which is actually just overcomplicating this because now you got to write it out to say this anyway. Then you got to use it again. So, but you could do that. You could say let that fancy I equal all real integers, and then instead here you could say x equals I as your answer. You could do it that way on the exam, but it's just easier to write all integers. Yeah, if you do it right, they would count it. But you do not have a lot of extra time on this exam. It's not as crazy as the ACT, where you've got to do like 60 questions, 60 minutes, like you got to move super fast. But most students take the whole time to take the test. Like there's probably a couple that they had to guess on and are going back and looking over whenever time's running out. So most students take the whole time or very close to it for this test. It is not like the EOCs when you were in 9th grade, whenever you got 4 hours to take that Math 1 exam, and there's one person left in the class taking the whole 4 hours. It is not like that. So you probably do not have time to get creative with your solutions. But technically, if it is mathematically correct, and you have explained it well, you can get credit for it even if you do something unconventional, if it's mathematically correct. So, all right. Okay, let's look at this one. Same directions, find all of the vertical asymptotes. So that numerator, we could factor x plus 4 and minus 2. Denominator factors into x plus 2, x minus 2. This only asks us for vertical asymptote. So what do we have at x equals positive 2? At x equals positive 2, which would correspond to x minus 2 here, we've got a removable discontinuity, a hole in the graph. So we would only have a vertical asymptote at x equals negative 2. I am being lazy by writing VA. I don't mind if you do it on your homework. I think we're pretty clear on what a vertical asymptote is, but only if you have to do that on a free response, write it out. Because there is no list of accepted abbreviations. There's some I know that they are going to accept, like D and E for does not exist. That is very widely used, and they are going to give you credit if you use it instead of does not exist. But I do not know that they would give you credit for VA there. So just go ahead and write everything out on that. If you're doing a test for me, quiz or test for me, or on the actual exam, write it out. Homework, I don't care what you do, but the way you practice is the way you play, so don't get too lazy with it. All right, so let's now talk real quick about what we've got to do for infinite limits. Okay, so those last ones were just asking us about vertical asymptote. It was sufficient for us to just look at where the denominator equals 0, and we could tell there was one there. This time, it is telling us that we're supposed to find the limit as x approaches 1 from the left of x squared minus 3x over x minus 1. And so if you notice, at x minus 1, the denominator is going to be 0 here. So like if I try direct substitution here, I'm going to get 1 squared minus 3 times 1 over 1 minus 1, which is 1 minus 3 over 0, so negative 2 over 0. What does it tell us when we get a number over 0? We do not use the word undefined. This is undefined, but we don't use that word for limit, so what would we say instead for the limit? So we would say that this limit does not exist. But sometimes they want a more specific answer than does not exist. So if it were multiple choice, does not exist may not be an option. You may only have positive infinity and negative infinity to choose from. So if you are able to graph it, just graph it, right? Graphing it will be the easiest thing to do here. But you occasionally see some of these where you cannot graph. And if you cannot graph, you're just going to have to make a table. And it's a pain in the behind, but you got to do it. So we are approaching 1 from the left. So we need numbers less than 1. I'm going to start with maybe like negative 1. So negative 1 squared minus 3 times negative 1 over negative 1 minus 1 is going to be 1 plus 3 over negative 2, which is negative 2. I'm going to plug in 0. 0 squared minus 3 times 0 over 0 minus 1 will give me 0 over negative 1. That's 0. Alright, I need a number closer. 0.5. I'm doing this without a calculator. I prefer fractions whenever I don't have calculators. So I'm going to go fractions. If you prefer decimals, you can do it. I don't like square. 0.5 is not that bad. I don't like squaring big decimals. So I got 1/4 minus 3/2 over negative 1/2. You can see this is pain, right? So this would be 6/4, because we got to get common denominators there. So we've got negative 5/4 over negative 1/2. Dividing fractions is easy as pie. Flip the second and multiply. So 10/4 or 5/2, 2.5 there. Alright. Looks like our numbers are increasing. So probably positive infinity. Probably to be just a little safer, I might go with like one more. Let's do 1/10. Hold on. No, not 1/10. 9. Yeah, let's do 3/4. 1/10 was the wrong direction there. So 3/4 squared minus 3 times 3/4 over 3/4 minus 1. So 9/16 minus 9/4 over negative 1/4. So that would be, we got to multiply with 4, so it'd be 36/16. So negative 27/16 over negative 1/4. So 27/16 times 4/1. Reduce there, that'll be a 4. I'll get 27/4. right, 27 divided by 4, like this was 2.5. 27 divided by 4 is, 4 goes into 27. It's like 6 and 3/4. So we're increasing here, right? And we know vertical asymptotes. We know there's a vertical asymptote here. So we know we're either going to positive infinity or to negative infinity. So that your answers are narrowed down to that. So although I would like to do this with a table in the calculator and feel a little more assured that this is going to positive infinity, I'm also sick of these fractions already. So I am going to assume here that the limit as x approaches 1 from the left of x to the third minus 3x over x minus 1 equals positive infinity. So this is kind of a pain. You got to plug some in by hand. But I have seen these where you have to do this, where it's calculator inactive. So we need to be able to do a few of them. There. Questions? All right. A few properties of infinite limits. So here they're telling us that the limit as x approaches c of f of x equals infinity, and the limit as x approaches c of g of x equals L, an actual number, right? So if we are doing the limit as x approaches c of f of x plus g of x, here, if I'm doing infinity, I get infinity for this one, plus a L, whatever that is, a number, infinity plus any number, is going to just give you infinity. Even if it's a negative number, even if you're subtracting, infinity minus 10 million is still infinity, because infinity is so big that it trumps everything else. Infinity times, if we got f times g, we're either going to get positive or negative infinity, depending on whether or not the g is positive or negative, right? So if this L value is bigger than 0, we'll get positive infinity. If it's less than 0, we'll get negative infinity. If we're doing g of x over f of x, think about what's happening here. G of x is L, f of x is infinity. So L is a number, could be any number, over infinity. If we have a number over infinity, that's sort of looking at like the limit as x approaches infinity of 1 over x. The bottom is so big that we might as well just say this is 0. And all of these are going to, something similar is going to apply for all of these with negative infinity also. So infinity is so big that really the only thing you can do to it is change its sign, right? If you multiply or divide by a positive or a negative, it can change the sign of the infinity, but it's not going to change it from being infinity. There. So to look at a couple more problems, if we look at this, we have the limit as x approaches 0. Here, we do have a vertical asymptote for this part right here, because this is our x squared right here. Be really careful, because like as I was thinking about this, I was like, oh, that answer is 1. What was I thinking? That the answer was 1. And why is it not 1? Okay, we're approaching 0. What was I thinking? Infinity. As x approaches infinity, this would go to 0. You would get 1 as your answer. But this question is not asking us about x approaching infinity. So be really careful. I have had a few students before that once I teach them how to do Bobo-Botno ECC, they go and take a quiz or a test, and they do Bobo-Botno on every single problem, whether it approaches infinity or not. But it only applies if x approaches infinity. So I just saw myself doing that right there. I was already in like the mode of what I was doing yesterday. I was thinking, oh, that's 0. You get 1 for this answer. So be really careful. We're looking at where x approaches 0 of this. So we need to think about what's going to happen really from either side here. So we're going to have, if I pick numbers smaller than 0, actually let's pick above first just because positive's easier to deal with. Like if I plug in 3, I got 1 plus 1/3. And 2 would be 1 plus 1/2. I'm sorry, not 1/3. It'll be 1/9. And then 1/4. If I plug in 1, I would get 1 plus 1, which is 2. Let's do like 1/2. So if I've got 1 plus 1/1/2 squared, that is 1 plus 1/1/4. How do I, dividing fractions, easy as pie, flip the second and multiply. So really this is just like 1 plus 4, which would give us 5 right there. So limit as x approaches 0 from the right of 1 plus 1/x squared, it appears that this is going to be positive infinity. Let's think about what's going to happen for negative infinity. If I make this a -3, is it going to change my answer? It will not, because the x is squared in that denominator. So this actually makes it convenient here. You get the same answer. If I make that a -2, same answer. -1, same answer. -1/2, same answer. So we're going to approach positive infinity from that side as well. So we would just say that this is positive infinity. Okay. Some of yours, I'm going to have you actually do that by hand. Not for too many because it does take a little while. And then some of them, I'm just going to let you use let's use the calculator. Desmos is so much better, but we need to be practicing with that calculator. So let's just use the calculator for this last one. So everybody try this on your calculator. Once you get it typed in and y equals, make sure that it looks right. And so, I'm going to look at the graph first, because if this is positive or negative infinity, it will be easy to see from the graph that that is happening. Although my graph looks terrible because my window is weird. So if you need to change your window on these, you can see F2 right there says zoom. So if you go there, it is number 6 is your like standard 10 by 10 zoom. So if you do 6, now when I look at this, alright, so whenever you put it in, You got to put parentheses around the numerator. So you'll have parentheses x to the second plus 1, close your parentheses, divided by, and then you got to have another set of parentheses around the denominator. And because it is also a fraction, you're going to have 1 over, and then you got to put parentheses around this x plus 2. And you got to double close parentheses there because you got to close 1 for the x plus 2 and then 1 for that bottom fraction. Alright, now when I look at my graph here, it looks like that should be a vertical asymptote, but actually because it is a complex fraction, it's turning out not to be. Right? What does it look like our answer is here? Looks like you're approaching 0 probably, right? To confirm for this, if we go to the table, so green button, F5 there will take you to the table. If your table is already set up where you're just asking, then you can just type in the numbers. If it's not, you can do F2, which is setup, and go down here to the bottom, change independent to ask, and then it'll just let you type in numbers, which is easier to do there. So we're approaching -2 from the left, so we could do like -4, -3. We could try -2, but I bet that's going to give us a... Does yours give you a 0? Okay. Where this is like a emulator of the calculator that may or may not be totally official, I'm not really sure. Sometimes it does weird things there. So it's giving me 0, but I think you guys are probably getting it fine. So if you do like -2.1, -2.01, -2.0001, you can see there your values are getting close to 0. So that sort of confirms what's happening there that you see from the graph. So you would just say 0 for that. So that one actually just ends up being whole. So, your assignment that you will have, and this will be due on Thursday. So what we're going to do tomorrow is we're going to work on the Part B progress check. So this will not be due until Thursday. So you will have some class time tomorrow probably, depending on how long it takes you on the progress check. So 13 through 25 odd, 30, these are just finding vertical asymptotes, not limits, so you're just looking at where that denominator equals 0 there. 37 through 49, odd, this is no calculator, so those are the ones you're going to have to sort of do that table for, plug in values with. 49 through, oh, I've got 49 both places. Let's make that 47 right there. So 37 through 47, those are no calculator. 49 through 59, you can use your calculator for.